Okay, this video is a review video, but it's to help us get ready for our quadratics test. And we're talking about the 4 different ways that we can solve quadratic equations. Now, all of these quadratic equations and everything that we do in this chapter is going to have an x squared. That's what makes it quadratic. And when you solve a quadratic, you're going to get 2 solutions. Now, the only real kind of hiccup or exception to this is that when you're doing the quadratic formula or when you're factoring, sometimes you still get 2 answers, but sometimes it's repeated. The answer is 5 and 5. So you just say 5 once. So it's not always going to be 2 separate unique ones, but there's 2 solutions. Okay, so on number 1, the first type of solving is going to be to solve by taking the square root. So on this one, I'm going to take the square root of both sides. Square root of x squared is x. The square root of 25 is going to be plus or minus 5. Because remember, this is a quadratic. It has an x squared. We have to have 2 solutions. And there are my 2 solutions. I'm not going to add an I because I'm taking the square root of a positive. Here, I'm going to take the square root of both sides, and I'm going to get plus or minus 9. But because this is a negative, the square root of a negative number is I. So I have to add an I in my answer. Okay, let's see what happens on number 3. On number 3, I take the square root of both sides, but that's not a perfect square. So I have to make a factor tree. So I'm going to have 12 and 10, 2 and 5, 6 and 2, 3 and 2. So I'm looking for pairs. So when I write my answer, I've got plus or minus. Each pair is one number outside of the radical. Anything not paired up gets multiplied back underneath. And because it was negative, I have to add an I outside of the radical. So now when I simplify this, I get plus or minus 2 square root. 3 times 2 is 6 times 5 is 30 I, and that is my answer. All right, on number 4, take the square root of both sides. I can't, it's not a perfect square, so I'm going to make a factor tree. So I have 2 and 42, 2 and 21, 3 and 7. So when I simplify it, x is going to be plus or minus 2 square root, because that's outside. Inside I have a 3 and 7, so it's plus or minus 2 square root 21. I do not add an I because I'm not taking the square root of a negative number. Okay, the next type of solving is to solve by factoring. To solve by factoring, the first step is to set it equal to 0, which this one already is. And the next step is to factor. And every time we factor, the first thing we should look for is greatest common factor, which it doesn't have on number 1. So we look and say, well, it's a binomial, and I can take the square root of both. So I'm going to go straight to my 2 parentheses. Square root of 4x squared is 2x. Square root of 49 is 7. 1 is a plus and 1 is a minus. So now that I have my 2 equations, now that I have it factored, I can write my 2 equations and solve. So one equation is 2x plus 7 equals 0. The other is 2x minus 7 equals 0. So in this one, I'm going to subtract 7. So I have 2x equals negative 7. Divide by 2. X equals negative 7 halves. Over here, it's the same thing, but I'm going to get positive 7 halves. And there are my 2 answers. It was a quadratic because it had an x squared, so I get 2 answers. Now, there's a lot of you that can probably do this work in your head. And if you can do your work in your head, then do that. You don't need to write it out each time. I want you just to see the factored form and get the answer. There's a lot of you right now that are still struggling to figure this out, so I wanted to write it out. Now, let's compare number 1 to number 2. They look almost identical, but on number 1, we have the difference of squares, and number 2, we have the sum of squares. So if we're starting to solve by factoring, we set equal to 0, that's done. And now we factor, so it's going to factor the exact same way. One's a plus, one's a minus, but because this is the sum of squares, we have to add an I. So everything is almost the exact same. The only thing different is when it's sum, we add an I. So now one equation is 2x plus 7i equals 0, and the other is 2x minus 7i equals 0. So here I'm going to subtract 7i from both sides. So I get 2x equals negative 7i. I divide by 2, so x is negative 7i over 2. Okay, sorry about the Awkward pause there. Okay, so if that one is negative 7i over 2, this one is going to be positive 7i over 2. Look how similar these are. The only difference is the I. And again, if you don't need to show the work, you don't need to. Okay, on the last one, that is not set equal to 0, so I'm going to add 48 to both sides. So first thing I do is try and factor, and I'm always going to look for the greatest common factor, which is 3. 48 divided by 3 is 16. Okay, and now I'm going to factor this further. And I'm not looking at the original, I'm looking at that. You always look at the step in front of you that you're factoring. So now the square root of x squared is x. The square root of 16 is 4. 1 is a plus, and 1 is a minus. But I'm factoring the sum of squares, so I have to add an I. Now, technically, I have 3 equals 0, x plus 4i equals 0, and x minus 4i equals 0. So when I solve, 3 cannot equal 0. That greatest common factor, when it's just a number, does not give you a solution. But here, when I subtract 4i from both sides, I get x equals negative 4i. Here I get x is positive 4i. Okay, the next one, we're going to solve by completing the square. So when we solve by completing the square, the first step is to take this positive 41 and move it to the other side. Now we did two things with completing the square. One, we rewrote it in vertex form, and two, we solved. But the process is very similar, so there's a lot of commonality and a lot of things to review here. So we're going to subtract 41 and then put blank. I don't need to put the 0 because adding 0 doesn't do anything. Equals x squared plus 14x plus blank. I did not need to factor anything out because my leading coefficient in front of the x was the invisible positive 1. So half of 14 is 7. 7 squared is 49. Because it wasn't in parentheses, I really added just 49. On the left, I get 8. On the right, now I'm going to factor that. So the two numbers that multiply to 49 and add to 14 would be 7 and 7. And since it's x plus 7, it's the same in both parentheses, I can write it as x plus 7 squared. Once you get the parentheses by itself, then you can take the square root of both sides. The right is easy because if you've got the square root and square root, they cancel, so I just get x plus 7. Over here, I have the square root of 8 that I need to simplify. So this is 2 and 4 and 2 and 2. So this is going to simplify to plus or minus 2 square root 2. To finish it off, I'm going to subtract 7 from each side to get x by itself. So when I write my answer, I always start with whatever number I added or subtracted from 7. So I'm going to have negative 7 plus 2 square root 2 and negative 7 minus 2 square root 2. Okay, let's try this again on number 2. On number 2, the first thing is to move that negative 22 over. So that gives me positive 22 plus blank equals, now this is not an invisible positive 1. So I have to factor out that negative 2. And when I factor it out, I'm factoring out from just these terms because that 22 is now on the other side. So negative 2x squared divided by negative 2 is x squared. And negative 12x divided by negative 2 is positive 6x plus blank. Okay, close my parentheses. Half of 6 is 3. 3 squared is 9. Now it looks like I added a 9, but I really added a negative 2 times 9, which is negative 18. So over here, 22 plus negative 18 is 4 equals negative 2. Now I need to factor this. What multiplies to 9 adds to 6? Well, it's 3 and 3. Because it's x plus 3, I just write it x plus 3 squared. Before I can take the square root, I have to get the parentheses by itself. So I'm going to divide by negative 2. 4 divided by negative 2 is negative 2. And this gives me x plus 3 squared. So now I've got to square root both sides. On the right, the square root and the square cancel, so I get x plus 3. Over here, I cannot simplify the square root of 2, so it just becomes plus or minus the square root of 2. But because there's a negative, I don't write the negative anymore, and I replace it with an I. So now to get x by itself, I'm going to subtract 3 from both sides. So I get negative 3 plus the square root of 2i and negative 3 minus the square root of 2i. All right, on the last page on the back, we're going to do the quadratic formula. So here's the quadratic formula. Now, the nice thing about the quadratic formula is once you have learned that, the part under the radical, this part in yellow, is the discriminant, and this part gives you the formula to find the x-coordinate of the vertex. So it's kind of a 3-in-1 deal. So you get three formulas for the price of one. All right, but now we need to use it as the full quadratic formula. So this is my A, this is my B, and this is my C. So when I plug it into my equation, I have the opposite of B, which is going to be -4 plus or minus the square root of B squared, which is 16, plus -4 times A, which is 2, times C, which is -9, all over 2 times A, which is also 2. Okay, first step, simplify under the radical. So -4 times 2 is -8. -8 times -9 is +72. Add 16 to that, and we get 88. So I have -4 plus or minus the square root of 88 all over 4. Now, before I go on, I need to simplify that. So with 88, when I simplify that, I get 8 and 11, 2 and 4, 2 and 2. So this simplifies to -4 plus or minus 2 square root. Now, not paired up, I have a 2 and 11. So underneath, that's going to be 22 over 4. And before we write our final answer, I'm going to reduce. I ignore what's under the radical and see if I can reduce the other things, which I can. And so my final answer, x is going to be -2 plus 1 square root of 22, which is the square root of 22 over 2, and -2 minus the square root of 22 over 2. So there are my two answers. Okay, let's look at number 2. On number 2, you can't plug it into the quadratic formula because it's not set equal to 0 yet. So I'm going to add 10 to both sides. And when I do that, I get x squared minus 5x plus 10 equals 0. So now that I've done that, now I know this is my A, this is my B, and this is my C. So the opposite of B would be 5 plus or minus the square root of B squared is 25 plus -4 times A is 1 times C is 10 all over 2 times A. Okay, let's simplify this radical. -4 times 10 would be -40. -40 plus 25 is -15 all over 2. And we can check, will 15 simplify? Well, if I make factor tray, I get 3 and 5, but there's no pairs. So no, it's not going to simplify. So when I rewrite it, I get 5 plus or minus. The square root of 15 doesn't simplify, so it's plus or minus the square root of 15, but I'm going to replace this negative with an I, and then it's going to be over 2. Now I can check. I'm looking at the 5, the 1, and the 2. Is there a number that goes into all three of those? Nope. So now I can write my two answers. So one answer is x equals 5 plus the square root of 15i over 2. And the other one is 5 minus the square root of 15i over 2. All right, last one. So I'm going to plug this into a quadratic formula. So I get A, B, and C. So the opposite of B is -12 plus or minus the square root of B squared is 144 plus -4 times A, which is 4, times C, which is 9, all over 2 times A. So I get -12 plus or minus the square root of -4 times 4 is -16 times 9 is -44. So if I have positive 144 and negative 144, that gives me 0 all over 8. So when I simplify this, I get -12 plus 0 over 8 and -12 minus 0 over 8. Well, whether you're adding 0 or subtracting 0, you're going to get the same answer. We've got -12 over 8, which doesn't divide evenly, but it does reduce to divide by 4, so we get -3/2. So if you want to write it twice, because quadratics have two answers, you can, but the reality is it's a repeated answer. It occurs once and it's a real number. Now notice on this one, my discriminant was 0, and I get 1 real number. Over here, my discriminant was 88, so it's a positive number, and I get 2 real numbers. On the last one, my discriminant was -15, and I get two imaginary. We know they're imaginary because they have an I in there. So all the rules about discriminants, it works. They all work together. It's all connected. Now in class, after we did this together, I gave them this individual worksheet. So if you want to stop your video and then try it and then come back and check it, you can. But here are the answers real fast. Okay. And I'm not going to hold them up too long. You can pause the video. 1 and 2 were the exact same from your notes. Okay, but when you're solved by factoring, set it equal to 0, and then factor, and then write your equations and solve. Because on 3 and 4, I was factoring a plus, I had to add an I. And then here are the answers for 5 and 6. 5, you're completing the square. 6, you're solving by the quadratic formula. And on 6, you're taking the square root of a negative number. So that's why you get the I. On 5, you're taking the square root of -4. The square root of -4 is 2, but you have to add the I because it's negative. And like I said, pause this and check your work on the individual worksheet.